Hi, and welcome to this flipped instructional session. This is Semester 1 of Earth Science. Today our topic is 4.13, Sources of Plate Motion Exploration, which is the teacher-graded assignment for Unit 4. I'm Mrs. Fessel, and let's get started. Just as a reminder that the theory of plate tectonics is that the Earth's crust is broken into pieces, called plates, that move slowly across the Earth's surface. You can see all of the plates of the Earth here, and these little red arrows are representing the direction that they are moving in. So as we said, it's broken into plates. The top part of the Earth is the lithosphere, and that's what the tectonic plates are made of, pieces of the lithosphere, which is the solid, rigid top layer of the Earth. The lithosphere includes the crust and the uppermost part of the mantle. Geologists group these together because they behave similarly. The lithosphere is solid and rigid, but when under stress it will break, such as into the pieces of the lithosphere. The tectonic plates float on a weaker layer of the mantle known as the asthenosphere. And one of the questions on this TGA asks, how can the asthenosphere flow if it's a solid? That's because it is plastic-like and capable of changing shape or flowing. Even though it's a solid, it can do this without breaking. So one of the other questions asks, why do the plates move? The short answer of this is gravity and convection. Gravity is what causes ridge push and slab pull, and convection is what creates these cycles or convection currents underneath the Earth in the asthenosphere, which we're going to go into more detail about next. So convection occurs because the center of the Earth down here is hot. This causes the asthenosphere to heat up, as we said, which is the uppermost part of the Earth's mantle that is plastic-like and capable of changing shape or flowing as a solid. When things heat up, they become less dense and rise. And that's what's happening right here in this cycle. The rock in the asthenosphere heats up, becomes less dense, and rises. This is similar to what happens in a boiling pot of water. The water heats up down here by the flame, becomes less dense, and rises. Then the opposite happens at the top here. The top of the Earth is cool. That's where we are, the oceans are, and that is cool. So it cools down, becomes more dense, and sinks. Then when it gets back down here, the cycle starts all over again. So this is an example of what the molecules might look like if we could zoom in. So we'll start here. This would be where the molecules heat up. They become more dense, spread apart, and rise. Up here near the surface, they cool off, group together, become more dense, and sink. And then as they sink, the cycle starts all over again as they heat up. So when the question asks what happens during convection, that's what we just talked about here. So how does gravity cause the plates to move? Gravity wants to pull all of the things towards the center of the Earth. That includes mountains and, for example, mid-ocean ridges. So right here we have ridge push. Gravity pushes the ridges back down into the center of the Earth, because that's what gravity does, pulls everything towards the center of the Earth. So gravity pulls down the ridges and the rest of the rock gets pushed down with them. So at a mid-ocean ridge, lava comes out and fills the gap with new igneous rock. This rock adds to the plate at mid-ocean ridges. The opposite happens at the other end of the plate. We get slab pull. Gravity, again, wants to pull everything towards the center of the Earth. So down here, it pulls that plate, or that slab of Earth, down into towards the center. So slab pull, the cool, dense crust at the other end of the plate sinks into the mantle, pulling the rest of the plate with it. So that's how gravity causes the plates to move too, through ridge push and slab pull. So at these mid-ocean ridges that we just talked about, this is what happens at them. The two plates right here are moving apart from one another, as both of these pictures show. As they move apart, there's a crack between them. Molten material from below the Earth's surface moves upwards, and when it hits that cool ocean water, it cools and hardens to form new rock. Older crust is over here at the edges of the plate and gets moved away from this mid-ocean ridge in either direction as new crust forms right here at these mid-ocean ridges to take its place. So then we have two plates. So that was two plates moving apart. Now we have two plates coming together. This is called a convergent boundary, which we're going to learn more about in the next few lessons and also in Unit 5. So many times when two plates come together, one plate goes under another. So as you can see right here, this plate, the oceanic crust, which is denser, thicker, and heavier, goes under the continental crust. So when that happens, oftentimes three things happen. First is this trench right here. You can see that these two plates form a V right here where they are coming together. That forms a deep trench. So that's one thing that can happen. The next thing that can happen is, as you can see, as this plate goes under, right here it gets hot and starts to melt. That melted magma rises, and as you can see right here, it forms volcanoes. So that's the second thing that can happen. Next, this plate is scraping underneath this plate as it goes under, and that can cause earthquakes. So the three things that can happen as two plates come together most frequently are a trench, volcanoes, and earthquakes. If it is two pieces of continental crust crashing into each other, such as the Indian plate crashing into the Eurasian plate, it can form mountains, such as the highest mountain range in the world, the Himalayas. So we were just talking about this a minute ago, but we'll go over it again. Two plates move apart at a divergent boundary, as you can see right here. Things that form here are a mid-ocean ridge. As we talked about, that's because the plates are moving apart. Lava comes up to take its place. Seafloor spreading, the seafloor is moving apart in opposite directions. And because magma is coming out of this crack, it can also form a volcano. So that is what can happen as two plates move apart. Finally, we have convection currents. And the TGA asks you, how are convection currents in the ocean and in the earth similar and different? Well, they both work in the same way. Warm material rises. In the case of the ocean over here, warm water rises. In the case of the earth, warm rock rises. The opposite happens on the other end in both. The cool rock sinks in the earth, and you can see here the water gets cooled by the ice, and the cool, dense water sinks. So they operate in the same way. Warm material rises and cool material sinks. The difference is what we just talked about. In the ocean, it's water rising and sinking, and in the earth, it's hot molten rock rising and sinking. That's the big difference. So that's all we have for today. Please attend the flipped follow-up, and we'll work on this graded assignment together. Have a great day. Thank you. Bye.